I'm Nicole Vitale and I'll be your teacher for today. Right now we're learning distance formula. So to start off with, the actual formula is x2 minus x1 in parentheses and then squared plus y2 minus y1 in parentheses squared. And then last touch, we put the square root symbol over all of it. Now, as we know up here, this is our first pair and this is our second one. So this is x1 and y1, and this is x2 and y2. Now, we just plug in the numbers. So we have x2, which is -4, minus x1, which is 1, in parentheses with our square root symbol, plus y2, which is 6, minus y1, which is 2, and then those also in parentheses with the square root. And we add our square root symbol. And now we just do the math. -4 minus 1. That's also like plus negative. So we have -5 in parentheses, the square root symbol, plus 6 minus 2 is 4 in parentheses with the square root symbol. And we add our square root.
Pause.
So next step is to actually square these numbers. Now, -5 squared will come out to be a positive number because a negative times a negative equals a positive. So pretty much we can just do 5 times 5, which is 25. And then we have our plus sign, and then 4 squared is 16. And we have our square root symbol. So we're going to go over here. So we have 25 plus 16. Alright, so that comes out to be 41. Square root. And, you know, you can always figure that out, see what the actual square root is, but most of the time, your teacher will just let you keep it as square root 41 because it isn't a perfect square root. So that would be your answer, and that is distance formula. And now we're on to area of sectors in the circle. And today we'll be finding the area of this small sector inside the whole circle. Now here are the formulas that we're going to need. So this is the actual formula for the area of this sector. And what we do is this is what we're looking for. So we take the total area, which is what we use this formula for, and we plug it in there, and then the measure of the degrees of just this sector over 360. And then we multiply it all out and find the sector area. So I'm going to do that right now. So we're going to start with the total area of the circle, which all we need for that is the radius. So we're going to do pi times our radius, which is 7, and then squared. It will all multiply out to 153.94. Okay, so that's what we have in that part of our equation. Now, we see there's a right triangle here, so that's how we know it's a 90-degree angle. So we have that here over 360 degrees. And now we just put an X here for our sector area. Now, what we can do is just cross multiply all of this out and then solve it. So that will be 360x equals 90 times 153.94, which will come out to be 13,854.6. And now we divide by 360. And the answer is 38.49. And don't forget to add your units squared on the end. And that is your sector area. And now we'll be doing Pythagorean theorem. So, right now we have two triangles, and one of them is missing a hypotenuse, and one of them is missing a leg. Now we're going to try to find these, and this is how you do it. We start with the actual Pythagorean theorem, which is a squared plus b squared equals c squared. Now the hypotenuse is always c. That's what c is. And the two legs are a and b. They're kind of interchangeable. It doesn't really matter which one's a and which one's b. So for this first one, we have our a and our b. So we plug it in and we do 4 squared plus 3 squared equals c squared. Now, we just solve for this, and then that's how we'll get the square root, or that's how we'll get c squared, and then we'll take the square root of it, and that will be c. So 4 squared is 16, plus 3 squared is 9, and that's going to equal c squared. Now, 16 plus 9 is 25, equals c squared, and we take the square root of both of them. This cancels out and just becomes c. And 25, the square root of that is 5. So now we know that c is 5. So this here is 5. Now this is actually something that we call a triple. And there are several of them where 3, 4, 5 works out perfectly. There's no decimals or anything like that. And any multiples of these numbers will also work in place. So if I were to do, instead of 3, 4, 5, if I did 6, 8, 10, it would also work because it's the same 3, 4, 5 multiplied by 2. So that's a triple. Now the next one that we'll be doing is missing a leg. Now, we have 13 and we have 12. This 13, since it's on the hypotenuse, isn't going to be added to the 12. This time, it's going to be on the outside. So with our a squared plus b squared equals c squared, 13 is going to go on the outside. It's going to be 13 squared equals, and then we can just put the 12 in the b slot. So 12 squared plus a squared. Now, once again, we just find what these are and then solve it algebraically. 13 squared is 169, and 12 squared is 144. And then we still have our plus a squared. Now we just subtract 144. And we get 25. So once again, we just put the square root symbol over both of them. That cancels out, and a equals 5, which is the square root of 25. So then once again, this becomes 5. And as you can see, this is an example of another triple because it works out perfectly between the three numbers and there are no decimals. So that's Pythagorean theorem.